So hi everyone. While your digestive system are smoothly kicking in after lunch, and your attention span is about 50% lower than it was an hour ago, I'm going to talk to you about plants and about how data, or the role of data in what we think is part of a solution for growing healthy plants for food, but also for other industries like pharmaceuticals and cosmetics. So we Jungle are not data experts. I just want to make that clear, though you'll very soon find out in 5 minutes that I'm not a data expert. But this is really about the perspective of an indoor cultivation company like Jungle, and what do we see as a user of data. What do we see data could bring to us in terms of future improvement opportunities, and what is the impact and the scope of data in the future of our business. So I hope from that all of you data geeks in the room, we will actually rely on you to crack the problem and to find solutions to help industry like ours to really leverage data, which is quite key over the next 5 to 10 years. Great. So, sorry, Guilherme, just one thing. The only thing we don't do is rooftop farming.
So I guess we
So what we call vertical farming, and it's pretty much 99% of people misunderstand or misinterpret, which means the word has been wrongly chosen. We only do indoor controlled environment cultivation. It can be basement, it can be inside a building, an office, a warehouse, but we don't do greening the cities or wall flowers and gardens or rooftop community exposed to sunlight and outdoor conditions. We only develop controlled environments purely indoors, so without soil and without sun. I think I just said it, but in main terms, what is really important in what we do is the highest possible level of environment control in the field of cultivation. Greenhouses are not too far from what we do, at the exception of the fact that we have a very hard job to do, which is replacing sunlight and light spectrum from the sun with LEDs. CO2 as well is another element that we control, and which can be actually pretty tough in a controlled environment. So here you have just a quick series of components and environment elements that we control in an indoor farm. Just a quick overview for you to understand about the categories of plants that we are able to grow nowadays inside an indoor farm. And this is what we're working on for next year. And here, of course, we're only talking about food plants. I've chosen, for the essence of time, not to talk about medicinal plants because it's another subject and would take too much time. Very briefly, why indoor farming? Those are the key advantages. The main problem or negative point of indoor farming today, which is raised by a lot of critics, and they are right, it's energy consumption. Besides the fact that an indoor farm consumes quite a lot more energy than an outdoor farmer, not so much more and sometimes less than a greenhouse, pretty much everything else is a no-brainer. Taste, shelf life, control of the plant over the year, water consumption, the fact that you can establish a long-term supply, everything is a pretty strong indicator that this has to be part of the future of how we grow food in some places of the world. Oh, sorry. So we have an R&D in Lisbon, an R&D center, where we develop and test equipment and hardware configurations, as well as growing recipes. And the word growing recipes is important because it's at the core of my last slides, which are much more data-driven. We talk about in indoor growing, we talk about a growing recipe. And the recipe includes how do you configure all your hardware components inside your farm, which seed you choose, which substrate, water temperature, how much oxygen, how much CO2. We even talk about lighting recipe when using LEDs to reproduce the spectrum of the sun. So this is what we test in Lisbon to basically find the optimum growing recipe for basil, for lettuce, for strawberries, and other plants. Right now we have about 520 data capture points in our system that record, depending on whether we follow up pH in the water or air temperature or relative humidity, we capture the values from those sensors and probes on average between half a minute to 2 minute intervals. And again, this is a very small system, it's 100 square meter. The big farms of the near future that we intend to build and operate will be over 5 to 10,000 square meters of growing area, which will produce 5 to 10 million plants a year. So you can imagine the number of data collection that would be a best practice in a large-scale facility. We would be talking about over 200,000 or 300,000 points of data collection. That's just to give you an idea of a micro farm, a small farm. So this is a simulation of a 45 square meter containerized farm next to a hypermarket that we are building for operations next January. But the real game is this one. What you see at the front, the small system, is the structure of the picture before. And what you see at the back is what we identify as the right critical mass. That's the smallest module we should actually build and operate to be able to break into economies of scale and have something that is financially and technically efficient. The key in a vertical farm is data and automation. And the cost of automation, as you imagine, is something that only makes sense to afford if you go beyond a certain scale. When it's too small, you cannot absorb the cost of automation. So that's just to give you an idea at scale of how big and how one vertical farming module is in the years to come. That's what you saw the slide before in picture. That's the very first prototype of a gravity-driven automated vertical farm that we co-built in Canada. So basically the plants, the side that you see here is the harvest side, and on the other side of the tunnel is the loading side. So you put trays with seeds on the loading side, and depending on the plants, 20, 25, 27 days later, you collect your tray and the plants are ready to harvest. And when you take out the tray, well, it's usually automated with a robot. When you take out the tray, the trays before naturally flow down with gravity. So that's also very efficient in terms of energy. So now let's dive into data. And here again, from the perspective of a user of data and not a data expert, what I'm trying to express here is, from our perspective, what is the type of data that we are able to collect or will be able to collect. And in the next slide, from that data, what do we need to basically crunch this data and what we could obtain out of it. And that's only a question. I don't have the solution. But we hope the solution comes from interacting with, I'm assuming, people like you guys who are here today, who know, technically speaking, or might have the vision of how this can be built. So we have three major categories of data that we collect. The first one is what we saw before. It's all the data that comes from the environment, from the vertical farm, from the hardware in the vertical farm. Irrigation, sensors, probes, every type of hardware we can place in the environment that basically records a piece of data, which on that side there is pretty much nothing to further innovate. Probes and sensors already exist for a while. There is very limited innovation in that side. Yes, we're going from wired sensors into wireless sensors, so we can move the probes and the sensors from one layer to another to compare whether temperature, humidity is higher or lower there, but this is basically hardware-driven data capture. The key then is to accumulate data. What we experience now after a year doing experiments in our Lisbon center is that small scale, even though we grow every day, 7 days a week, that small scale is far from enough to accumulate sufficient data to be able to start playing around with algorithms or predicting a growing recipe for a plant. So at scale growing and being able to accumulate and to accumulate data over time from as many different centers as possible is key. The third point, as I was telling you before, is something we have to solve if vertical farms are going to succeed, is energy consumption. So in correlation with all this data we are getting from the hardwares and probes and components, monitoring energy consumption in the facility is very important, so that can be a driver or a point of focus to optimize over time. So we have our hardware-driven pieces of data on one side. The second area of data, which is the toughest one to actually register in high volumes and quantities, is everything related to quantitative and qualitative data of the plant once you harvest it. And here we are talking about very simple things that all of us can have a different opinion or judgment on, which is actually quite tough to treat as data, is the shape, does the smell is nice or not, is the color pleasing, is it too green, is it too yellowish, the biomass, the weight of the plant when we harvest it, that's easy to measure though, and all other criteria that the end user or the consumer of the plant will judge. Now, if you're selling plants to a supermarket, mainly what they will care about is the weight and the caliber of the plant. Is it the same every time? If you're a chef, you care more about the flavor, anyway there is no packaging, whether the plant is a little bit more on the right or the left, he doesn't care, but he wants a nice texture, he wants a nice taste. If you're a pharmaceutical company, what you care about is not really the looks of the plant, but it's the biological compound or the active compound inside the plant. So all of those are qualitative and quantitative criteria. That leads me to the third point, and I wanted to isolate the medical or cosmetics or pharmaceutical side from the food side, just because they care more about what's inside the plant and what can be extracted and used for a medical purpose. Now, that's a third layer of complexity, because smell, shape, taste, you don't need heavy machinery to actually assess it and rate it and record the data. But if you want to isolate a biological compound inside the plant and extract it from the plant and measure it, you can imagine that it's much more complicated, costly, and how can you do that on a massive scale to integrate this data into your future algorithm. So now we know the type of data that we are collecting in a vertical farm, and I'm getting to, well, I'll show you first. Now that's really hammering, now that you're deep into digestion. So this is an example of what we can measure, test, and the answers we get from it. This is exactly what we would love to be getting from an artificial intelligence algorithm in the future, which we're pretty sure is possible. So what you have here is you have photosynthesis and evapotranspiration as criteria that are being tested. Evapotranspiration, just very quickly, is the amount of water that a plant transpires through the leaves, and photosynthesis I don't need to explain. So you have those two criteria that are studied, and they are studied into two different contexts. One is their response to CO2, to the level of CO2 injection inside the vertical farm. And you can see the other environment criteria. PPFD is the intensity of the light, the temperature, the vapor deficit, and we've basically been playing around with a plant called Fragaria ananassa, and we've been playing around and registering the data and the reaction of the plant in terms of biomass. So how much biomass do we get from this plant when we inject 500 ppm CO2, 1000, 1500 and 2000? And the same on evapotranspiration. And then you have the correlation of the four that basically tells you that if you want to boost biomass of the plant, if this is your objective, which would be the case, for example, for supermarkets or mass retail, you want something big as quick as possible, you want substance and not necessarily flavor, well then you know that you need to configure your farm and your environment, your temperature and everything to those optimum levels of CO2 as well as light intensity in order to optimize biomass. So what are the prospects and why should we at some stage spend more time and try to crack this equation of big data and artificial intelligence into the future of growing plants? Basically, the first challenge that we see is establishing a correlation mechanism, or how do we correlate the three different categories of data that we're collecting in order to define a model of growing recipes for the plants. We talked about quantitative, qualitative, and all those criteria that are sometimes difficult to register as data. If we can find a mechanism for making this data talk to each other and correspond to something, to a common language, if we can do that and then at the same time design an algorithm that we learn from the data we collect of those plants, we will be definitely able to use this algorithm to lead into a stage where we can do on-demand farming. Now, what I call on-demand farming is very simple. Imagine you're a group of restaurants. You have this particular style of cooking, and you want your mint and your aromatics and your vegetables to be more peppery, more spicy. You want to have shiny reddish colors into your plates. You define your criteria for that plant. And with all the data that we have, we know that if we put more red into the LEDs, it will change the coloration of the plant. We know that giving wind stress to the plant 3 days before harvest will make it more spicy, and this is true. We've already checked that. So imagine if you have an algorithm that knows exactly what kind of configuration leads to what kind of flavor or profile of the plant. Well, we will be able to process an order and to grow plants on demand with that level of customization. And this is really what we believe is the future in this context of indoor cultivation. Now, there are far more important and significant contexts of using that than just making more spicy mint or more sweet basil. Imagine for medicinal purpose, for cancer patients. We know that they are macronutrients in the plants that are not good for the nutrition of cancer patients. With that, we will be able to grow a certain range of vegetables that have less potassium, more magnesium. We can express certain biological compounds of the plant without modifying its DNA. So it's all about building that back end, that algorithm that will use the data we generate to create a various number of plant profiles and help us basically configure our very precise growing environment to grow plants on demand. And eventually, what I meant by our plants-controlled indoor farm is that we can also imagine that the vertical farm of the future will be controlled by the plants themselves and no longer by a grower that will sit behind a computer, which is the way we grow plants nowadays. We have all our indicators and live dashboard, and based on the plants and how they look, we say, okay, the pH is a bit low, let's increase the pH, add a bit of acid. We believe that the future, and this is, I mean, the solution will come from you guys, that the vertical farms will be autopiloted by the plants themselves. So that's the prospect that we have for the future of growing plants, mainly in very high density urban centers. Obviously, Portugal doesn't make much sense due to the blessed climate that we have in this country. I don't know if there is no time for Q&A, or I don't know if it was part of the structure. But anyway, thanks for.
Nicolas, I have a question.
Yeah.
How scared should we be when you have the power to manipulate to such a far extent, what you grow, like how because we've spoken of ethics in the morning.
Yeah, okay, I understand the question.
It's not a provocation necessarily.
No, but you're right.
It's a complex
and thank you for having the opportunity to answer that. We are not doing any genetic modification to the plants. We are very humbly only trying to reproduce what's outside, inside. And data is not dangerous in itself.
It's not poison in itself.
It's what you do with it. But we are just capturing data from plants that we are growing with zero pesticide. So we are actually, on the marketing side, we are trying to create a new category of produce. We're trying to run away from the biological and organic, which is extremely vague and gray area, and many consumers are lost and they don't really know what it means. We don't like that. So what we're saying is we're growing zero pesticides plants, and the only way you can do that is by giving them the best sunny day every day of the year. So I'm not scared by that.
Well, we should. Thank you very much.
Thank you.